we think we are standing still. You sit in a chair, you feel the ground beneath you, and you trust that you are stationary. The human brain is wired to ignore the motion of the machinery we live on. But you are not still. The Earth is spinning at roughly 1,000 miles an hour. It is orbiting the Sun at 67,000 miles an hour. And the Sun is dragging our entire planetary system around the center of the Milky Way at 500,000 miles an hour. But that is just the local machinery. When you zoom out and look at the Milky Way itself, you realize that our entire galaxy is not drifting peacefully through the void. It is falling. We are plunging through the universe at 1.3 million miles per hour. A massive cosmic river of galaxies, all flowing in the exact same direction. We are being pulled. Something with the gravitational mass of tens of thousands of galaxies is dragging our entire cosmic neighborhood through the dark. But we do not know exactly what it is, because the universe has a cruel sense of irony. The monster that is dragging us through the void happens to be hiding in the exact one place in the sky we cannot look. We are hurtling toward an executioner, and we are wearing a blindfold. Let's begin. To understand the sheer horror of a galaxy in freefall, you first have to understand how we know we are moving. In space, speed is relative. If you are floating in an absolute void with no stars, you cannot tell if you are moving at 1,000,000 miles an hour or sitting perfectly still. You need a reference point, a background to measure yourself against. For the Milky Way, that reference point is the oldest light in reality, the cosmic microwave background. 380,000 years after the Big Bang, the universe cooled just enough for the first light to travel through space. That ancient radiation is still out there. It permeates every single inch of the cosmos. It is the glowing wallpaper of the universe, sitting at a uniform temperature of roughly 2.7 degrees above absolute zero. Because it is everywhere, it acts as a universal speedometer. In the 1970s, astronomers began measuring this background radiation with extreme precision, and they noticed a distortion. The radiation wasn't perfectly even. In one half of the sky, the microwave background was slightly warmer. The light waves were compressed, shifted toward the blue end of the spectrum. In the opposite half of the sky, the background was slightly cooler. The light waves were stretched, shifted toward the red. It is the Doppler effect playing out on the largest canvas in existence. When a police siren speeds toward you, the sound waves compress and the pitch goes up. When it speeds away, the sound waves stretch and the pitch goes down. The universe is doing exactly the same thing. We are slamming into the ancient light of the Big Bang in one direction and leaving it behind in the other. The math is undeniable. The Milky Way, the Andromeda Galaxy, and the dozens of smaller dwarf galaxies that make up our local group are not expanding outward evenly. We are engaged in a synchronized, violent plunge. We are falling at 600 kilometers every single second, 1.3 million miles per hour, straight toward a coordinate in the southern sky near the constellation Centaurus. If you know you are falling at 1,000,000 miles an hour, the first thing you want to do is look down. You want to see what is pulling you. When astronomers pointed their optical telescopes toward the constellation Centaurus, trying to find the source of the immense gravity dragging our galaxy, they expected to find a monster, a massive, undeniably dense supercluster of galaxies. Instead, they hit a wall. They saw nothing. Not because the space was empty, but because they were physically blocked from seeing it. We think of the Milky Way as our home, but in this specific scenario, our galaxy is a prison. The Milky Way is a flat, spinning disk containing roughly 100 billion stars. But it is not just made of stars. It is choked with an unimaginably thick soup of interstellar dust and cold gas. Because our solar system is embedded inside this disk, trying to look out into the broader universe along the galactic plane is like trying to look through a sandstorm. The dust absorbs and scatters visible light perfectly. It creates an opaque, suffocating band that wraps entirely around the night sky. Astronomers call it the Zone of Avoidance. It obscures roughly 20% of the extragalactic sky in visible light. 1/5 of the cosmos is permanently hidden behind the dust of our own home. And by an act of sheer, terrifying cosmic irony, the gravitational anomaly pulling our galaxy through the dark is located exactly behind the thickest, most impenetrable part of the Zone of Avoidance. Our own galaxy is acting as a blindfold. We are caught in a current, rushing toward a waterfall, and the hull of our own ship is blocking the view. For decades, the anomaly was simply a ghost in the math. We couldn't see it, so we gave it a name that reflected its terrifying, invisible power. The Great Attractor. But human curiosity does not tolerate a blindfold. If optical light could not pierce the sandstorm of the Milky Way, astronomers knew they had to change how they navigated the sky. They had to stop looking and start listening. They turned to radio astronomy. Specifically, they began listening for the 21-centimeter line, a very specific frequency of radiation emitted by cold, neutral hydrogen gas. Radio waves do not care about interstellar dust. They slice through the dense, suffocating clouds of the galactic plane, as if they aren't even there. Using massive satellite dishes, like the Parkes Observatory in Australia, astronomers blindly mapped the radio echoes coming from behind the Milky Way. They combined this with X-ray telescopes capable of detecting the extreme heat of distant galaxy collisions. Slowly, the Zone of Avoidance began to render. And what they found in the dark was not a single massive black hole. It was not an impossibly large dark planet. They found a graveyard. Behind the dust, roughly 150 million light-years away, lies the Norma Cluster. It is a massive, incredibly dense collision of galaxies. When X-ray telescopes finally pierced the veil, they saw the signatures of unimaginable violence. Entire galaxies being ripped apart by gravitational tides. Millions of stars being thrown into the void. The intergalactic gas in the Norma Cluster is superheated to tens of millions of degrees by the violent shocks of galaxies colliding and merging. It is a gravitational pileup on an apocalyptic scale. But as astronomers measured the mass of the Norma Cluster, the dread only deepened. The cluster is massive. It contains thousands of galaxies. But it is not heavy enough to pull the Milky Way, Andromeda, and millions of other galaxies across the universe at 1.3 million miles per hour. You need an incomprehensible amount of mass. Tens of thousands of galaxies worth of gravity. The Norma Cluster was just a breadcrumb. It was not the executioner. The Great Attractor was not a physical object at all. To understand what the Great Attractor actually is, you have to stop looking at galaxies as individual islands and start looking at them as water flowing down a mountain. In 2014, a team of astrophysicists mapped the velocities of 8,000 galaxies in our cosmic neighborhood. They didn't just map where the galaxies were, they mapped the specific direction they were falling. They realized that the universe is structured like a watershed. If a drop of rain falls on a mountain range, gravity dictates its path. Drops that fall on one side of a ridge flow down into one specific valley. Drops that fall on the other side flow into a different valley. When they mapped the currents of the cosmos, the blindfold finally fell away. They discovered that the Milky Way is not an independent structure. We are just a single drop of water on the very edge of a massive cosmic watershed. They named it Laniakea, Hawaiian for the immense heaven. Laniakea is a supercluster, a sprawling, branching web of 100,000 galaxies, containing the mass of 100 quadrillion suns, and it is 500 million light years across. We are not falling toward a single heavy object. We are caught in the gravitational current of Laniakea. The Great Attractor is simply the bottom of the valley. It is the gravitational focal point where all the dark matter, gas, and galaxies in our supercluster are destined to pool together. We are sliding down the threads of a spider web, drawn inevitably toward the densest knot in the center. But the terrifying truth of the universe is that there is always a bigger monster. Just as we started to comprehend the sheer suffocating scale of Laniakea, the math broke again. The Great Attractor is incredibly massive. It is the dense gravitational heart of our local supercluster. But it is not sitting still. When astrophysicists calculated the total mass of the Great Attractor, they realized it still wasn't heavy enough to account for the total speed of our cosmic river. The math demanded even more gravity. So they looked past it. Hundreds of millions of light years behind the Great Attractor, hiding even deeper in the dark, they found the Shapley supercluster. It is the most massive concentration of galaxies in our local universe. A towering gravitational behemoth containing the mass of 10,000 Milky Ways. The Great Attractor is not the bottom of the valley. It is just a ledge. Our entire Laniakea supercluster all 100,000 galaxies, including the Great Attractor itself, is being dragged toward Shapley. The executioner that is pulling us through the dark is, in reality, just another victim being pulled toward a larger abyss. We are caught in the wake of giants, being dragged by strings that are held by even larger puppets. But the universe rarely allows us to feel comfortable with our maps. Even after discovering Laniakea and the Shapley supercluster, the mathematics of our violent plunge through the cosmos did not perfectly align. The mass of the Great Attractor, even when combined with the colossal weight sitting behind it, was still not enough to explain our full velocity. We were moving too fast. The pull of the gravity ahead of us could only account for half of our speed. In 2017, physicists looked in the exact opposite direction. If the gravity in front of us wasn't strong enough to pull us at 1.3 million miles per hour, what if something behind us was pushing? They looked away from the Great Attractor, away from the dense, glowing webs of Laniakea, and out into the absolute dark on the other side of the Milky Way. And they found the twist. Directly behind our local neighborhood of galaxies is a region of space that defies comprehension. It is not a supercluster. It is not a wall. It is a void. An immense, staggering emptiness, hundreds of millions of light years across. A region of space almost entirely devoid of galaxies, stars, and dark matter. In the delicate physics of the cosmos, gravity is a pull. But a lack of gravity acts as a push. If you are standing between a massive, heavy mountain on your left and an absolute empty vacuum on your right, the mountain doesn't just pull you. The vacuum repels you. The emptiness itself creates a gravitational slope. Astronomers named it the Dipole Repeller. It is the ultimate cosmic vice. We are not just falling toward the Great Attractor. We are being violently expelled from the dark. The Milky Way is caught in the middle of an ancient war between density and nothingness. The heaviest structure in our local universe is dragging us by the throat, while the emptiest void in reality is pushing us in the back. We are running from a ghost straight into the arms of an executioner. So, what happens when we finally arrive? What happens when the Milky Way, after falling through the dark for tens of billions of years, finally reaches the center of the Great Attractor? What does the collision look like? It doesn't. He will never arrive. This is the final suffocating irony of the Great Attractor. We are falling at 1.3 million miles per hour, but the universe is not a static room. The very fabric of space is expanding, driven by the relentless, invisible pressure of dark energy. And dark energy is accelerating. At the local level, gravity wins. The Milky Way will eventually collide with Andromeda. We will merge into a single massive elliptical galaxy. But over the vast, crushing distances of Laniakea, gravity is losing the war. The Great Attractor is roughly 150 million light-years away. At that distance, the expansion of space is happening faster than our physical plunge through the universe. Imagine running on a treadmill. You are sprinting forward as fast as you can, moving at 1,000,000 miles an hour. But the belt beneath your feet is accelerating in the opposite direction. No matter how fast you run, the destination is physically moving away from you. We are hurtling toward the Great Attractor, but dark energy is injecting new, empty space between us and our destination, faster than we can cross it. We will never hit the bottom of the valley. In the deep, unimaginably distant future, the expansion of the universe will become so violent that it will physically tear the Laniakea supercluster apart. The dark matter webbing will snap. The cosmic river will run dry. The Great Attractor will recede into the absolute dark, pushed over the cosmic horizon by the expansion of space, until the light from its galaxies can no longer reach us. The Dipole Repeller will expand until it consumes everything behind us. The Milky Way will be stranded, an isolated, lonely island in a freezing, rapidly expanding void. We spent decades terrified of the monster hiding behind the dust of our own galaxy. We were terrified of the collision. But the truth is far more tragic. The universe isn't going to let us crash. It is just going to pull the floor away and leave us falling in the dark.